Hello, I'm starting section 6.3 today on the rational numbers. So we have covered so far, we have covered the following sets of numbers. We did the natural numbers. The natural numbers are the counting numbers. The whole numbers are the natural numbers and the zero. And we did last time the integers. Which are going to be, the integers are the whole numbers and the opposites of the rational numbers. Okay, so in this section, we covered the rational numbers. So the word rational comes from ratio, and those are going to be the ratio, numbers that can be written as the ratio of two integers, or simply the fractions. So this is on page 258. Now it's going to be difficult to list the elements one by one. And we are going to, we can write them in set builder notation, but I'm just going to read the definition. The set of rational numbers, which we will denote by Q, to remind us of quotient, is a set of all numbers that can be written in the form A over B, where A and B are integers and B does not equal 0. The top number A is called the numerator and the bottom number B is called the denominator. Okay, so numbers, let's write numbers such as 1/2, 7 over negative 13, negative 4 over 5, and negative 20 over negative 9. Are examples of rational numbers. And you can also write integers. Well, you can consider also integers rational numbers with denominator 1. Like numbers like 5. So also numbers like 5, negative 3, and 0 are rational numbers. Because they can be written in the form of 5 over 1. Like 5 can be written as 5 over 1. Negative 3 can be written as negative 3 over 1. And 0 can be 0 over any other integer. Okay, so we can write the same rational number in different ways. Like 1/2, we can write it as 2/4, or we can write it as 3 over 6 or 5 over 10. So we need to define when two rational numbers are equal. So we define equality of rational numbers as follows: A over B equals C over D, if and only if A over D equals B over A times D equals B times C. So what we do is just cross multiply. So just cross multiply, and AD equals BC. And that one is a D. Okay, so we're going to do an example on equality. We're going to go over example 1. Okay, we will determine, so let's copy example 1. We will determine which of the following pairs of numbers are equal by cross multiplying and comparing the products. Okay, so number 1, or part A, 3 over 8 and 12 over 32. Chances are that you know how to reduce fractions, but let's suppose that you have never done that. So let's cross multiply 3 times 32, compare it to 12 times 8, or 8 times 12. 3 times 32 is 96, and 8 times 12 is also 96. So they are indeed equal. The next one is 39 over 116 and 35 over 108. So let's compare. Let's do the cross products. 39 times 108 and 35 times 116. Now that one is more difficult to reduce, but let's compare the products. 39 times 108 is 4,212, and 35 times 116 is 4,060. So these numbers, these rational numbers, are not equal to each other. A part C. Cross products, that's 220 times 1,419 and 165 times 1,892. So both products are 312,880, or 180. So these fractions are equal. 1419 and 1892 is equal to 165 over 220. So in some cases, we can cancel common factors to reduce the fraction, to write the fraction in simplest form. So we learn how to write the prime factor decomposition of a number, and you can always cancel common factors. Yeah, I'm not even going to copy that. I mean, I'm not even going to give you the page number. So this rule says that we can cancel the same factor from both the numerator and denominator of a rational number. This process of canceling common factor is called reducing the rational number. And when all common factors have been canceled, we say that the number is in lower terms. So we are going to, okay, we're going to reduce the following rational numbers. Okay, let's start with 99 over 117. So we can reduce the rational number by canceling common factors. Both numbers are divisible by 9. We learned the divisibility rules. When the sum of the digits is a multiple of 9, the number is divisible by 9. So 9 plus 9 is 18. We can factor this as 9 times 11, and 117. The sum of the digits is 1 plus 1 plus 7, which is 9. We can factor that as 13 times 9. Or 30, 9 times 13. So we can cancel the 9s, and 99 over 17, or 99 over 117 can be reduced as 11 over 13. B. We will reduce negative 1056 over 660. Okay, so initially using the divisibility rules, we can see that they are both divisible by 6 because they are divisible by 2 and divisible by 3. So negative 1056 divided by 6, it's negative 176. And 660 divided by 6 is 110. Okay, so we can cancel the 6s. Then 176 and 110, they are both divisible by 2. 176 over 2 is 88. And 110 over 2 is 55. And 88 and 55, they are both divisible by 11. And that's as far as we can go. So this reduces as negative 8 over 5. Okay, so we're going to do arithmetic with rational numbers. The first two operations are going to be addition and subtraction. So addition and subtraction of rational numbers. Okay, so if two rational numbers have the same denominator, simply add the numerators. So if you want to add or subtract two rational numbers with the same denominator, simply add the numerators. and don't change the denominators. So you want to do something like 8 over 6. 8 over 6 plus 7 over 6. Same denominator, so we just need to add the numerators. 8 plus 7 is 15. 15 and 6 are both divisible by 3. So that's what? That's 5 times 3 and 2 times 3. And the result is going to be 5 halves. Otherwise, if they have different numerator and denominator, we can do two things. We can cross multiply or use the least common multiple of the denominators, known as the least common denominator. So these are on page 261. So if the denominators are different, a over b plus c over d, what you can do is multiply the denominators and then cross multiply the numerators. So that's a times d plus b times c over b times d, and same with your subtracting. The denominator is going to be the product of the denominators and then cross multiply. So that's going to be a times b minus b times c over b times d. So you can do that or use the least common denominator. So you have, at the end, you will have less reduction of fractions. So use the least common multiple of a and b, known as the least common denominator. Or LCD. Couple of examples. Let's find 3 over 8 plus 5 over 6. So we can use, instead of cross multiplying, we can use the least common denominator. Let's find the least common, or the least common multiple of 8 and 6. So 8, it's 2 times 2 times 2. That's the prime factorization, and 6 as a product of prime is 2 times 3. Okay, so they involve 3 2's and 1 3. The least common multiple is going to be 2 times 2 times 2 times 3, which is equal to 24. So back to the fraction, 3 over 8 plus 5 over 6. The least common denominator is 24. 24 over 8 is 3, so we're going to multiply by 3. And 24 over 6 is 4, so we're going to multiply 5 by 4. 3 times 3 is 9, 5 times 4 is 20, and 9 plus 20 is 29. So we cannot reduce this fraction any further because 29 is a prime number and it doesn't have any factors that are common with 24. And B. Let's subtract 9 over 16 and 3 over 12. Yeah, so if we try to cross multiply, we're going to have a significantly large number. 16 times 12 is going to be a large number, so we can use the least common multiple of 16 and 12. So let's write the prime factorization. 16 is 4 times 4, or 2 times 2 times 2 times 2. Let's keep the multiplication symbols consistent. And 12, it's 4 times 3, or 2 times 2 times 3. So the least common multiple is going to be, we have 4 2s and 1 3. So the least common denominator is going to be 48. That way we don't need to multiply 16 and 12 because that's going to be 192. So it's easier to work with 48 than 192. So 9 over 16 minus 3 over 12. Least common multiple is 48. 48 over 16 is 3, so we multiply 9 by 3. And 48 over 12 is 4, so we multiply 3 by 4. 9 times 3 is 27. 3 times 4 is 12. (27 minus 12 is 15. Both numbers are divisible by 3. So 15 over 3 is 5. And 48 over 3 is 16. The final answer is going to be 5 over 16. Okay, so that's how multiplication and division works. I mean, that's how addition and subtraction works. And multiplication and division are actually easier than addition and subtraction. Or more straightforward, we don't need to worry about the least common denominator. Especially multiplication is easier than addition or subtraction. Okay, so the multiplication is very straightforward. And actually they do, they illustrate with this figure. Let's say you want to multiply 3/4 by 5/6. So we can divide a rectangle into 4 equal parts and into 6 equal parts. So we have 3/4 and 5/6. And then if you overlap the rectangles, you're going to have 15 pieces in common. So 3 over 4 times 5 over 6 is going to be 15 over 24. So the multiplication is nothing but the product of the numerators over the product of the denominators. So we are going to find and simplify the products. One. Four over 7 times 7 over 9. Okay, if you want, you can multiply 4 times 7 and 7 times 9. That would be 28 over 63, but there's no need to do that. You can just, if you multiply them, at the end, you're going to be canceling common factors. So the 7s are common factors, and that reduces us 4/9. Or you could have done it directly here. The way this is given, you could have just gone ahead and cancel the 7s. So we have 4/9. B. Find and simplify 20/27 times 18/50. Okay, so I'm going to write on a separate line. You can do it right there if you want, but that's 20/27 times 18/50, where 20 and 50 are both divisible by 10. So 20/10 is 2, 50/10 is 5. And 18 and 27 are both divisible by 9. 18/9 is 2, 27/9 is 3. We have next 2 times 2 over 3 times 5, or 4/15. And part C, 12/5 times -9/10. Okay, so we can see a couple of common factors. So 12 and 10 are both divisible by 2. We can reduce those as 12/2 is 6, and 10/2 is 5. So this is what? This is 6 times -9 divided by 5 times 5. And the fraction, or the rational number, is going to be -54/25. So we can write the minus on the numerator, the denominator, or we can just go ahead and write it in the middle. And the last thing I'm mentioning today is division of rational numbers. So if you have a fraction over a fraction, the numerator is going to be the product of the outside numbers, and the denominator is the product of the inside numbers. So when you have that, that's also on page 253, 263. So the numerator is going to be the product of the outside numbers, and the denominator is going to be the product of the inside numbers. So A/B divided by C/D is A/B times D/C. Another way to write it is that A/B divided by C/D. What you do is keep the first one as it is and multiply, and flip the terms of the second fraction. That's another way to do it. So the last two examples are going to be divisions. We are going to perform the following divisions. we're doing first 35 over 12. 35 over 12 over 5 over 4. Okay, so that's going to be the product of the outside numbers and the product of the inside numbers. The product of the outside numbers is 35 over 4. Or 35 times 4. So that's 35 times 4 and 5 times 12 or 12 times 5. And we can reduce a couple of things. 35 and 5 are divisible by 5. 35 over 5 is 7. And 5 over 5 is 1. And 4 and 12 are both divisible by 4. 4 over 4 is 1, and 12 over 4 is 3. So final answer is going to be 7 over 3. This is 7 times 1 over 3 times 1, or simply 7 over 3. And last one for today, I will finish the section next time. It's negative 13 over 9 over 7 over 6. Okay, so that is going to be negative 13 times 6 over 9 times 7, or 7 times 9. And we can reduce the 6 and the 9 as 2/3. 6 and 9 are both divisible by 3, so 6 over 3 is 2. 9 over 3 is 3. Okay, so that's negative 13 over negative 13 times 2 over 7 times 3. Negative 13 times 2 is negative 26. And 7 times 3 is 21. Okay, so this is what I'm doing in this video. Next time I'm going to finish the section. So thank you for listening.